Welcome everyone, Math 105. This is Lesson 19, Percent Applications. So cent is the Latin word for 100. And there are quite a few English words that have cent in it. Got things like centipede, century. And the word percent can be read as per cent or out of 100. And so a century is 100 years. And now in mathematics, the percent is defined to be a fraction over 100. So n% is that number n divided by 100. And we're going to be able to use this definition of percent to convert between percents and decimals. So when we divide by 100, a shorthand way of doing that is just moving the decimal 2 places to the left. So if we want to go from the percent to the decimal, we're going to move the decimal 2 places to the left. All right, so we'll start to the right of the 5, move 2 to the left, and get 0.45. Usually put a 0 point out front, just so we can make sure to see the decimal point. So these two things are equivalent to each other. 45% means the decimal 0.45. So B, we're going to move 2 places to the left and get 1.73. So for any percent that's greater than 100%, we're going to get a decimal representation that is greater than 1. And 100% then would equal 1 exactly. Right, now I've got 1.2% here, so when we move this to the left, we're going to run out of digits, so we're going to have to add a 0 on. So that'll be 0.012. Right, we've gone from between the 1 and the 2, 2 places to the left to get between the 2 zeros. And then for the last one, we've already got 1 0, and we're going to move 2 to the left. That's going to give us 2 more zeros, so we'll have 3 zeros to the right of the decimal. Your turn, number 1. Convert those to decimals. Just a reminder to pause the video, work on the your turns, and then come on back. All right, this one, 2 to the left, is going to give us, we have no zeros, we're going to have 1, 2 zeros, so 0.0038. Next one, starting to the right of the 4, moving 2 to the left, gets us between the 6 and the 3, 26.34. So here's another example of something more than 100% that gives us a value greater than 1. Now here we've got 2 zeros to the right of the decimal. If we move it 2 to the left, that's going to give us 4 zeros. So 1, 2, 3, 4 zeros, 2, 9, 7. And then 25%, 0.25. Now we're also going to convert decimals the other direction. So to go from decimals to a percent, we're going to change this formula around a little bit. We'll start with the definition of percent. Now what I like to do is I want to get n by itself. So I'm going to multiply both sides by 100. And since we're dividing by 100 here, if we multiply by 100, those hundreds are going to cancel out. And so that gives us n equals 100 times n. So that means if we want to go from the decimal version, n is the decimal version, to the percent, we have to multiply n by 100. So to go the other direction, we're going to multiply by 100. And that means we're going to be moving the decimal 2 places to the right. Now we're going to take these decimals and convert these to percents. So moving the decimal 2 to the right, same as multiplying by 100, and then add the percent sign. So 20.23 is 23%. 0.004, move 2 to the right, be just to the left of the 4, so that is 0.4%. For 3.98, move 2 to the right, that gives us 398%. So a value more than 1 gets us a percent more than 100. And then 37 to the right gives us 3,700%. So these two operations are often confused with each other. So just make sure you understand that the percent is always larger than the decimal. Your turn, number 2. First one, we've got 3 zeros, so we're going to move to the right, so we'll have 1 0. So 0.037%. Like this one, we're going to move 2 to the right, that gets us just to the left of the 2, so that's 0.21%. And then 14 to the right gives us 1,400. Add a couple zeros there, 1,400%. And 0.86 to the right gives us 86%. All right, next up, we're going to be translating equations or sentences into equations. And to do that, we've got some keywords. So of, it's going to be multiplication. Is, as usual, that's the equal sign, just as we saw during translating equations. What number? That kind of a phrase, that's your variable. That's our unknown. And then find, that's n equals. So find is a combination of what and is. So find would be like what is something. So example 3, we're going to translate what number is 10% of 50. So what number? That's our variable. So just make up a letter. N is fine. Is the equal sign. Now 10%, whenever we encounter a percent before we use it in a formula or an equation, you've got to convert it to a decimal. So move 2 to the left. And that turns into 0.1. And of is multiplication. And 50. Now we multiply, and we get n is 5. So 5 is 10% of 50. Your turn, number 3. What number is 20% of 75? So what number? That's our unknown, that's our variable. Is the equal sign. 20%, convert this to a decimal. That is 0.2. Of is multiplication. And 75. So 0.2 times 75. So n is 15. So 15 is 20% of 75. Now, another ways these can be phrased is 20% of what number is 59, or 25%. All right, 25% convert to a decimal, so that's 0.25 of multiplication. What number? There's our variable. Is the equal sign, and 59 on the end. So we're not going to be able to just multiply like we did last time, right? Actually going to have to solve for n. So we're multiplying by 0.25. So that means to get n by itself, you need to divide. And 59 divided by 0.25 gives us 236. So 25% of 236 is 59. Your turn, number 4. 40% of what number is 6? Right, 40% as a decimal is 0.4 of its multiplication. What number? That's our unknown, so a variable. Is the equal sign, and 6 on the end. Right, divide each side by 0.4, and that gives us 15. So 40% of 15 is 6. Another variation of this one is example 5. What percent of 60 is 15? Now, when I'm trying to find a percent, I usually just use p just to remind myself that we're finding a percent. It's not necessary, but I like to do it. So what percent? P of multiplication. 60 is the equal sign, and 15. Now we're going to solve for p, so divide both sides by 60. 60's cancel on the left. Divide on the right, and we get p equals 0.25. But the question didn't ask for a decimal, it asked for the percent. So we need to convert this to a percent with the decimal to the right. 25%. So most of these are going to involve a decimal conversion one way or another. If it's given to you in the problem, you're going to need to convert to be able to do the math. And if the question's asking for it, then you need to convert the decimal to a percent. Your turn, number 5. What percent of 220 is 77? So translating, what percent is our variable? Of is multiplication, 220 is the equal sign, and 77. Now solve for p. Divide that, and we get p equals 0.35, which is 35%. All right, now we're going to look at some word problems, and we're going to use these translation skills to create equations from the word problems. So the strategy is make sure you read the problem carefully, identify what is being asked for, and create a variable to represent this quantity. And to write out exactly what this variable represents, including units, and that definition will help you write the sentence or the answer. Now translate into an equation. It can be helpful to rewrite the given information into a little sentence using these keywords of and is and things like that. solve the equation with algebra, and then check the answer and make sure it makes sense, and then answer the question with a complete sentence in units, and you can use your variable definition to write that last sentence. So example 6, on the first day of a fund drive, a charity raised $3,500, which is 14% of their goal. How much is the charity trying to raise? So the question asks for what's the total amount of money. So that's where we're going to define our variable to be. So T is defined to be the total fundraising goal in dollars. And now what we know is that they've raised $3,500. So in words, we could write this out as $3,500 is 14% of the goal, right? So now we can translate this into an equation. So we have 3,500. Is this the equal sign? 14% to the left gives us 0.14 of its multiplication, and the goal, we define that to be t. Now we can solve this for t. So divide both sides by 0.14, and that gives us a t of $25,000. Your turn number 6. Anna saved $1,950, which is 65% of the amount she needs for a used car. How much is the car? So we need a variable. The question is asking for how much is the car. So I'm defining T to be the total cost of the car in dollars. And now we know that $1,950 is 65% of the total. Now we can translate this into an equation. 1950 equals 65%, convert to a decimal, we got 0.65 of as multiplication, and the total, we define that to be the variable t. Now solving for t, divide by 0.65 on each side. And that gives us t is 3,000. So $3,000 is the total cost of the car. Now another type of percent problems is the percent increase decrease problem. And this is a very important problem because it comes up so often. So what we're going to do to find the percent increase decrease is to first find the absolute increase or decrease. So that's just the amount something changes. And then we're going to take that absolute increase and divide it by the original amount. And that gives us the percent increase as a decimal. Convert it to a percent and we're all set. So example 7. Gas prices increased from $2.15 per gallon to $3.29 per gallon. Find the percent increase in price. All right, so first thing we want is the absolute increase. So we ended up at $3.29 and we started at $2.15. So we'll subtract those two numbers. And that gives us an increase of $1.14. Right, now we're going to take that $1.14 and divide it by the original amount. And the original gas price was $2.15. Now, how did we get this? Well, what we want to translate, the sentence we want to translate is the increase is what percent of the original amount. This is basically the question we're asking. So the increase, which was $1.14, is the equal sign, what percent? P of, and the original amount, $2.15. So if we want to solve for P, we divide both sides by 2.15. And now P equals 114 over 2.15. So that's where this comes from. But you don't have to show all this every time. You can just go right to the formula. So we divide that out. We get P equals 0.53. And so as a percent, we're going to move that 2 to the right, move the decimal, and get 53%. So that means gas prices increased by 53%. And what that means is we take 53% of the original amount, $2.15, and then add it to $2.15. So 53% of $2.15 is $1.14. Add those together and we get $3.29. Your turn, number 7. Last year, the price of a 1-pound ribeye steak was $8.49. Now it is $10.29. Find the percent increase in price. So the increase, we take the new amount, $10.29, subtract the original amount, $8.49, and get 1.8, so $1.80. So we'll take that 1.8, divide by the original price, 8.49, and we get 0.21. Move the decimal 2 to the right, and that's 21%. So the price of ribeyes went up by 21%. Next up, things don't just increase, they also may decrease. And now we're going to find percent decrease. So Sarah started the track season running the 400-meter dash in 78 seconds. By the end of the season, she ran the same race in 67 seconds. Find the percent decrease in her 400-meter time. So there's a couple of different ways to think about this. We can find the increase, subtract new minus old, and we're going to get a negative number that way. And it's often that the standard is a positive number is an increase and a negative number is a decrease. So I'm still going to call it an increase. But it's negative, so that makes it a decrease. All right, so new time minus old, 67 minus 78 gives us negative 11. All right, now we're going to divide that by the original amount. All right, negative 11 divided by the original time was 78. So this is where I tend to see the most mistakes, is people dividing by the wrong number. Always divide by the original amount. So that gives us P equals negative 0.14. Move the decimal 2 to the right, and we get negative 14%. So Sarah's time decreased by 14%. Your turn, number 8. Roger, the goalie on hockey team, averaged 3.4 goals against last season. This season, he averaged 2.3 goals against. Find the percent decrease in his goals against. So the increase, new minus old, gives us negative 1.1. Now we're going to divide that by the original amount. His original goals against was 3.4. So we'll take negative 1.1 divided by 3.4 and get negative 0.32. Move the decimal 2 to the right and we get negative 32%. So Roger's goal against average decreased by 32%. All right, our last application today is the simple interest equation. All right, there's our simple interest equation. I is the interest. P, like I said, is a capital P in the equation. P is the principal, so that's the amount put into the account originally. R is the interest rate as a decimal, and T is the amount of time. Now, R and T have to be kind of coordinated. So if the interest rate is per year, the time has to be measured in years. So example 9, Sal invested $5,000 in a certificate of deposit which pays 3.4% annual interest. How much interest will Sal earn after 5 years? All right, so we are going to calculate the interest using this formula. So we're given that Sal put $5,000 into the account. That's the principal. That's the original amount invested. So I equals 5,000 times, and then we have an interest rate of 3.4%. Converting that to a decimal to the left gives us 0.034. So that's the number we need to use in the formula. Never use a percent in a formula. And we're investing in it for 5 years, so multiply by 5. I multiply all those out, and we get 850. So Sal will earn $850. Your turn, number 9. McKenna invested $2,000 in an account that pays 8.25% annual interest. How much interest will McKenna earn after 3 years? Right, so she is investing $2,000 at 8.25%. Move it to the left, we get 0.0825 as the rate, and it's for 3 years. Multiply all that out, and we get 495. McKenna will earn $495. Example 10. Alejandro has the opportunity to invest in an account that pays 5% annual interest. He would like to earn $3,000 in 3 years. How much does he have to invest? So this time we're not solving for I. How much to invest? That's the principal. So we'll be solving for P. Now he would like to earn $3,000, so that's the interest. So the 3,000 goes in for I. P is going to be a variable. The interest rate is 5%. Move the decimal to the left, we get 0.05, so that's the rate. And the time is 3 years. Now to solve this, we're going to need to simplify on the right, so multiply those two together. And that gives us 0.15 times P. If we divide both sides by 0.15, we get P is 20,000. So Alejandro needs to invest $20,000. Your turn, number 10. Joy is going to invest in an account that pays 6% annual interest. She would like to earn $2,000 in 4 years. How much does she need to invest? So she wants $2,000 in interest. So 2,000 goes in for I. We don't know how much she's going to invest, so P, the principal, stays the variable. And 6% interest, that's 0.06. And the time is 4 years. So So multiplying on the right, 4 times 0.06 gives us 0.24. So we have 0.24p. And divide both sides by 0.24. And we'll round that. So Joy needs to invest $8,333.33. Now another version of this asks for the interest rate. So example 11, in 5 years, Steve paid $9,000 in interest on a debt of $15,000. What was the interest rate? So the interest is $9,000. The debt was $15,000, so that's the principal. The rate, we don't know. Leave that a variable. The time is 5 years. All right, simplifying the right, we're going to multiply 15,000 times 5. So that's 75,000 R. Now divide both sides by 75,000. We get 0.13. Move the decimal to the right, and that is 13%. So the interest rate on the loan, not the interest rate, the interest rate on the loan was 13%. Your turn, number 11. In 2 years, Deb paid $25.60 interest on a debt of $8,000. What was the interest rate? So we're given that Deb paid $25.60 on a debt of $8,000. $8,000 the principal, and that was over 2 years. So multiply together 2 times 8,000, you get 16,000. So you have 16,000 R on the right. Divide both sides by 16,000, and R is 0.16, which is 16%. So Deb had an interest rate of 16%. Sounds like your average credit card. Example 12. How long would $6,000 need to be invested at 4% interest in order to earn $1,200? So now we're solving for time. We want to earn $1,200, so $1,200 will be the interest. We're investing $6,000 at a rate of 4%. So 0.04 for the rate, and we don't know the time. That's what we're solving for. All right, simplifying the right, 6,000 times 0.04. So that is 240. Divide both sides by 240, and t is 5 years. It'll take 5 years to earn $1,200. Your turn, number 12. How long would $10,000 need to invest it at 2.5% interest in order to earn $2,000? So 2,000 is what we want to earn in interest, 10,000 is the amount invested, and 2.5% as a decimal is 0.025. So first thing we'll do is multiply these two together. So 10,000 times 0.025 is 250. Divide both sides by 250. Divide that out, we get 8. So it will take 8 years. And that is it for today. I hope you all have a great day.